Hi there, Turgeon here, bringing you physics from afar. Sound. What is it? Obviously, it's something that you can hear. You can hear me speaking right now. You can hear ambient sound around you. Obviously, this is a unit on waves. A lot of people know it's a vibration. A lot of people, if you, even as you're speaking, you can feel the vibration in your vocal cords right now. But what is sound completely? It's really like a phenomenon. It doesn't really make sense to say it's just this one thing, like it's just a vibration by itself. And also, when you think about how you're going to measure the sound, you got to think about what aspect of the sound you want to measure. You can see in this simulator, we've got a speaker playing a sound. You can see the waves going through space. Obviously, this is the simulators allowing you to visualize that. We wouldn't be able to see these normally. Compare this to water, right? You could look at a side view of the water dropping in, creating these waves, and you can see that there's amplitudes that are decreasing. We're going to talk about why. This receiver represents what the wave is doing at a different location. But the sound, if you change from a side view to a top view, looks the same because it's not expanding just as a circle. It's not expanding in a line. It's expanding as a sphere. It goes everywhere. Think about it. If I snap my fingers, there might be people all around me in the room. You could even put a microphone on the ceiling. It's going to pick up that sound everywhere because it goes everywhere as a screen, as a sphere. So let's think about this. Sound, there's 3 words to describe it, including a compression wave. These 2 words are words that we've learned already. Think about that. You can pause the video and write all this down and think about what we're going to fill in the blanks. Now, we know that the speed of sound, it's around 343, and it actually travels at a constant velocity. Now, we're not talking about the wave shaking. We're talking about it moving from place to place. So if I snap my fingers, it's how fast that wave went across the room to your ear. So it just uses distance equals rate times time. D equals VTV for rate or velocity. It goes fastest through solids and liquids. Fastest through solids, which is the opposite of what a lot of people think. We have 2 aspects of sound. We have the frequency and we also have the amplitude. The frequency is heard as the pitch. This word right here is pitch. Now that frequency stays constant at the source and at the medium and at the receiver. So if we go back to the simulator, this source is generating a certain frequency. And that frequency, if we were to measure it here, right here, and you count how many waves per second, believe it or not, you'll get the same as the number of waves per second way over here. The frequency is the same everywhere. Now, what's really interesting that I want to mention is if we think about what's happening physically in this air, like what is it about the air? If you just look at air in a silent room, this is what it looks like. Now, I don't know how well this is picking up on the simulator, or on the video, but these are wiggling particles. Now, if I turn this on, you can see that the disturbance goes through the air, but this air molecule near the speaker is not the same air molecule near your ear. There's a chain reaction. They pass along the frequency from one to another, but the frequency is the same everywhere. You'll notice though that the intensity decreases. Check it out. Look at how this wave is rather gentle looking. Look at when I put it over here. Way more intense. That's the loudness. So here's all of those answers. I also made a note here that this is faster in warm air. So to summarize, what is sound? Sound is a wave, but it's specifically longitudinal and mechanical like we learned. And you got to remember there's a source, a medium, and a receiver. It travels in all directions as an expanding sphere. And the 2 things that we could measure are these characteristics. We can measure the pitch, we can measure the frequency. Sound is a wave. This has been Physics from Afar.